Good morning. My name is Charles Sindelar, and I'm with SimpleFi Solutions. And today we're going to be doing a webinar on SAP Predictive Analytics with business planning and consolidation. So, promise, not going to do a lot of slides. I think I got a total of 9. And then we'll get right to covering predictive analytics and BPC. So just real quick, what we'll be talking about today, real brief introduction as to who SimpleFi Solutions is, overview of what we'll be doing in the demonstration, defining what predictive analytics is, and doing the demo in predictive analytics, and then watching that data migrate into BPC. At the end, we should have time for questions. We'll be taking the questions via the webinar text entry of the questions. So if you have questions along the way, you can put them in queue, and we'll get to them at the end. So who is SimpleFi? We are a consultancy that's 100% dedicated to SAP solutions. We have SAP recognized expertise in performance management. We are SAP partner, as well as SAP software reseller. We have a strategic focus on predictive analytics, BPC, planning consolidation. We do the various flavors of BPC, including embedded, optimized, NetWeaver, and Microsoft as well. We do SAP Analytics Cloud, and we do the data integration that supports all that. On the BPC side of things, we have 10 years of experience with BPC. And our consultants have about 8 years of experience working with SAP. And if that doesn't quite make sense, how could we have 10 years versus 8? It's because BPC was not always an SAP-owned product. So we go back to the Outlook soft dates. As far as what our firm focuses on, really implementation services, managing those projects, support, and upgrade. And our goal really is 100% referenceable customers. Just real quick, some of the offerings. We can assist you with annual budgeting, sales, planning, capital planning, headcount, staff planning, expense planning, cash flow. We can do consolidation, P&Ls, balance sheets, rolling forecasts, predictive analytics, intercompany matching, all sorts of print-ready ad hoc reporting. And report automation is a big focus for us. We like to basically help you build reports and then set those reports to run automatically at the month close, so you don't spend time generating print-ready reports and PDFs manually. You have the system to it. So what are we going to talk about today in this demonstration? Really what, as technology progresses, we've had the ability to collect data at an ever-increasing level of granularity. We can get data at the SKU, store, customer level, but we can collect all this data, but how do we make a meaningful sales plan with all this data? And then, use this very granular sales plan to compare it to actual results. If you tried to do this by hand in Excel, it would take a great deal of time, and you'd have to make some broad-based assumptions to figure out this level of granular plan. Now with the advent of, kind of machine learning, it's possible to kind of automate this very, very low level of planning and to produce a forecast or plan that you can load into a tool like BPC and have a plan that you can compare at a very granular level to your actuals. So just a little bit on what predictive forecasting is, just so everyone's kind of on the same page. So predictive forecasting is taking actual information, running statistical analysis and regression against it to provide a forecast of what's into the future. So how we're doing that is we're taking, in this example, we're going to be taking some historical sales data. But you can take all sorts of different kind of information and put this in the modeler to drive your future plan. Why would you want to do this? You can use it to automate your prediction of sales and costs. You can use it to have a starting point for your sales and costs that you'll model further. You can use this to improve your inventory management and manage pricing and expenses proactively. So what are some of your typical forecast inputs? You'll be using like units sold over time. You can use CRM information, industry data and trends for kind of high-level macro assumptions, and put it in the predictive tool and generate your financial forecasts for sales, costs, P&L, product trends, a capital plan. So this kind of shows the evolution of planning, right? We start on the left-hand side with basically raw data, clean data, and then we can get some standard reports that we can use to feed our plans. Now with a tool like BPC, you kind of are able to get ad hoc reports, and you can drill down on the data and do some analysis. Kind of once we go past that dashed line, we're kind of moving into what the future and where companies that are more sophisticated in their planning are starting to use predictive analytics tools, predictive modeling, and then kind of like the final part of this is taking your predictive modeling and then using that to run optimization scenarios for different outcomes of profitability. So the tool that we're going to be using to create our predictive model today is an SAP tool called Predictive Factory. And what this does is it lets us take data from our actuals, which we've collected, and analyze a huge pile of data very quickly, and then generate our unit forecast that we're going to bring into BPC. The tool itself is designed for a non-technical user. That being said, you don't need to be a mathematician or a statistician to use this tool. It's designed for a finance person with some education of how to use the tool to be able to maintain and model themselves. It uses predefined algorithms, and it fits various algorithms to the data you provide, trying to train itself on the data to provide accurate forecasts. And we'll see that when we go through the demonstration today. The tool itself has very low IT footprint. Once it's set up, it is basically user maintained. You can have IT assist with some of the data inputs from HANA and other data sources. It's a little more sophisticated, but the modeling itself is completely within the realm of the end user. So now we're going to actually go into the system and do a predictive model. So this model that we're going to be looking at today is basically we're building a unit forecast by SKU for each store. So what we're doing here is basically going to build an individual regression model and prediction for every store and for every SKU sold in that store. So each store will have a set of unique models for each SKU that they sell. And this is just one scenario that you could use this tool for. There are many others. So we're going to start by just adding a new model in our system. and we're going to be using a time series forecast model. So what that means is we are going to be building a model across time. So for us, that's going to be a 12-month sales forecast. So give the model a name, and then we're going to look at our data set. So there are all sorts of different options with this system. It can connect to all sorts of different kind of data. It can connect to HANA. It can connect to flat files. To keep things simple, we're just using a flat file today, but there are many different data connectors that you can use. And the idea here is, once you kind of set up the model, you can retrain it as new data comes available by rerunning the model against a modified data set for training. So what we're going to do here is we're going to pick a signal variable. So that is going to be the variable that we're going to predict. So this is called the dependent variable. And actually, if we just go back for a second and look at the signal variable list, we can see another variable there. That's the units sold variable. The units sold variable is for statisticians, that would be our independent variable. So what we're using here is the last 12 months of sales to provide an input for the prediction of our sales plan by unit. We could use a variety of inputs. We could use, if we were, let's say, doing a hardware store and we sold snowblowers, we could use one of the variables that we could put in here would be average number of snowfall inches by month by store location. And then we could use that to create a model. And then we could also put that out into the future if we had some kind of snowfall forecast for 2018, and the model would look at that data and automatically determine whether it would be a useful variable for this individual SKUs that it's planning. So when it came to snow blowers and shovels, the SAP tool would see that that is a meaningful relationship. The snowfall is meaningful as a predictive value for shovels and snow blowers. It would also realize that the inches of snowfall is not a relevant variable for screwdrivers. So you can put a whole set of data in here of information, and as the modeler goes through, it will select excuse me, the variables that are meaningful for each individual model or each individual SKU at each individual store, and build a forecast that's specifically tailored using a specific model just created for that. And that's one of the powers of this tool, is that to do that by hand would take a lot of energy, especially, and it would take a lot of knowledge. You could say for another seasonal product that would be lawnmowers. It will pick up on the fact that lawnmowers are not a product that is sold in any great units in the winter. It would say, and it would be able to time when the spring comes in different geographic areas. When do you need to have those units available to be sold? All right, so that's a little bit of talk about the units. We have to tell the system itself what the time variable is. So the time variable on this basically says we're using monthly data. We want a monthly forecast. We're using 12 months of historical data. We are then going to segment that data. The segmenting of that data basically says what is the granularity that we want to create these individual models. So here I call it customer, but the customer is really the store and the product. So it will build for each store a individual model for each SKU at each store. And that's how we tell the machine to do that. Select that. If we had variables in our data set that we wanted to exclude, there's an option to use the excluded variable option. This would be for some fine tuning on the model. We're not going to do that today, but it's certainly one of those things that will help when you have a large data set that you're looking at. If there are things that you know going into the modeling that you don't want to be included, you can exclude them. So we're going to train the data set on this, and then we're going to train it on all the data that we're providing it, and then we're going to ask it to provide a forecast of 12 months. So at this point, we would normally click Save and Train, and the machine would iterate through all these different permutations. But for the purposes of the demo, I'm not going to make everyone sit around on the call and wait for that to happen. So we're just going to skip that set of steps, and kind of like a cooking show, we're just going to take the pie that we just made out of the oven and it's all ready to eat. So what we have here is our different models. So we're going to drill into that. So SAP has created a whole host of models for us, and we're going to open that up. It will take a second to load because there's a lot. So basically, for each store, it's created a SKU regression. So we're going to start looking at the data itself. So it provides all sorts of statistical information about each model. There's some reports, but we're going to jump to the segmentation. And the segmentation itself really, I think it's the best illustration of what we've done here with the data. And so the first one we're going to look at is for a cleaning supply product at one of our stores in Florida. And we're going to pick the forecast. Give it a second there to render. So this is a very interesting graph to me. The actual data is the green line. So the green line represents, for the specific cleaning product at a specific store, the actual data that's historical for the 24 months of historical data that we fed it. You can see in the blue line, that is the model that has been created automatically by the Predictive factory. And you can see it's a pretty close correlation. There's a little bit of a gap here and there, but basically it's spot on. Towards the end of it, in the last 12 months on the chart, you can see our forecast. There's no more blue line. This is the forecast of the units that we would be selling. So if we look at that, we can see that there's definitely a bump in the winter months, both in December and in January, February, March. Why is that? This is because we have snowbirds and vacationers coming to Florida, and there's more people in Florida during the winter months. Therefore, we're selling more cleaning products. And you can't necessarily tell from this graph, but when we've looked at it in a little more detail with some of the statistics, not only is it capturing the seasonality of the product, it's also capturing a slight growth trend. It's like 3%. So you could kind of see that the December months are higher than the prior year. So all this was done automatically. It didn't require any thinking on the end user's part to capture the seasonality other than setting up the model as we just did. And it captured all that on its own for every SKU at this store. The next SKU, we're going to back out of this and look at a different SKU and see how it captured it as well. The product that we're looking at now are the little bottled bubbles that you get in the store, that the kids like to play with. So I'm going to look at that SKU. We're going to go again to the forecast tab. So here, once again, following the same kind of graphical outlay, you can see in the green that we have the actuals. The blue is the predicted value. So for the first 24 months, it's very closely correlated. We then have a subsequent time period where there's a prediction. So what do we learn from this one? We learn here, and it's kind of obvious to anyone who has kids, but the machine figured it out, and it didn't require any input from us other than the raw data, that during the summer months, kids are out of school, it's warm out, and they have more time to bother their parents to buy them bubbles to play with in the backyard. And you can see that that's pretty closely modeled in the summer months, kind of starting in May and ending in August. So now that we've basically been able to generate a model for all these different SKUs, and this is in units, what do we do with it, right? So we have seeded a unit forecast, but we need a way to model that with a sales price and a cost of goods sold to get our gross margin plan. So we use BPC to do that. So we're going to switch out of predictive analytics and go into BPC. For those who've never seen BPC, we have lots and lots of webinars on it. Just a 2-second overview on what it is. Basically, it is an Excel-driven tool that the end user interacts with. They can input data and extract data from it, and it has a logic engine on the back that can do some pretty sophisticated calculations. It can do everything from various types of sales planning, like we're showing here, to stepwise consolidations. So today, we're kind of keeping things simple in the purposes of the demo. We are just going to be doing our gross margin plan. So to kind of start off here, what we've done is we have, by the way, this is BPC 11. There are many different versions of BPC. This is BPC 11 on HANA, and it is what is referred to as BPC standard, not embedded. So what we're going to do here is we'll load through a data package, and it's very straightforward, the data out of we'll load it out of the predictive factory output into BPC. So we got to connect. Give me 1 second to connect here. Timed out my connection. So what we'll do is we'll get this information out of the predictive factory, and then it will reside within BPC. Okay, so we'll go to run package, load our units, and we would basically click, and the package will run. Once we've run the package, it's loaded our data into our HANA database, and BPC will also run on various other versions, but we're not going to get into that. We'll refresh this, and we'll be able to see our unit forecast now in BPC. So this is at a higher level, but you can see now we've loaded a forecast into 2018. And for statistical purposes, if we want to analyze our, the predicted values against history, we've loaded that as well. Obviously, it's more for kind of noodling through and reviewing assumptions. You're not going to be using a historical forecast as part of your sales planning, but it's there if you wanted it. So now that we've got our units in, we need to create a gross margin plan. And we will do that by taking price information and cost per unit information. So with BPC, you can load this kind of information from various SAP systems like APO, or you can type it in directly into BPC itself through purposes of an input template. So we have some price per unit and cost information already seeded here, but for the stain remover spray in line 19, I'm going to update the price because I feel like it. And there's also going to be a price and cost of goods sold increase. So let's say I'll type in $9 for the price per unit. And I will say, my cost per unit is now $7. You can see here as I type the stuff in that the background color changes, thus alerting me that I've done something different. It's also this kind of a friendly tool here. The cells in yellow are the input cells, so you don't try and directly input margin per unit or something. So I've entered this data. I'm going to now save it back. It wants me to confirm. So what it's doing now, it's taking that cost information across. The way I have this set up, it's basically the cost is going to go against all stores, but you could make it more granular if you wanted, have individual costing for each store. But that would be, maybe something you want to model in the predictive analytics. So now you can see that it's recalculated the margin per unit and the margin percentage for that particular product. All right, so now that I've done that, I want to move into my profit and loss statement. So now we're really kind of getting into the power of BPC. We've created a margin forecast by providing the system with three inputs really. The units we're going to sell, the cost for those units, as well as the price. And that will give me the margin. So we're just going to refresh here and pull that information in. And this is at a consolidated level. So we're not looking at the individual stores, but we're looking at a higher level. And we can see, the revenue, the cost of goods sold, the gross margin percentage for the entire year. What BPC allows us to do is to slice and dice that data into different views and generate reports if we want them, or output it. It's all stored in this HANA database, so you don't necessarily need to provide reports to people anymore. You can provide them a report like this, and they can self-service the data that they want to see. So in this example, I'm going to say, all right, I'm looking at my total sales plan. I want to, as the end user, I have a question perhaps about some sales in August. So I will go click on the time period. It'll pop up a window, which is very easy to use and select August. I will then just refresh it, and the whole report changes in front of me to be that particular August. We won't get into how these reports are built, but the report building tool does not require you to build your own query. Doesn't require anything more than being able to drag and drop rows and columns in and having some knowledge around formatting. If you're good at Excel, the tool will become very innate. It's very similar to a pivot table in Excel. So now we've kind of got this information, and more finance-driven folks will appreciate it, that it's numeric and in Excel, because that's the tool that they like to interact with, or at least most of the people that I run into who are finance people. But the salespeople, tend not to be huge Excel fans. So how can they interact with this data? We can go look at a dashboard that comes with the BPC tool. So the BPC 11 tool has some dashboarding capabilities. So what we see here is kind of a user landing page, and it can be customized. So you can have graphs and charts and to-dos all on your home page, and it's customized to stuff that you're interested in. It is customized to what security you should be able to see. If you are a high-level sales director and are supposed to be able to see all the information company-wide, then you will be able to see all the information company-wide. If you're only supposed to be seeing information from Florida, and that's the view we have here, you will only see the information for the Florida regions. So what we can do here is, we'll start with the pie chart, is we can take a look here at our, right now when it opened, the revenue was already displayed for us. What we can do is we can change that drop down to gross margin. What is our, where's our gross margin being driven? Just as soon as we drop down, the graph changes, and we can see that laundry detergent is our big profitability driver because we have a relatively limited selection of data that we're looking at. And we can see that the bubbles that we looked at, really not a big factor in our gross margin, but it's well represented on this graph. If we scroll down to where we have the product trends, we have our 2018 forecasts, and we can see the units sold, the gross margin, and the revenue all in that graph, and we can select between different product groupings. So right now it's set to bubbles, and we can click on the drop down there and select cleaning supplies. And you can see basically as soon as you unclick it, the graph dynamically updates. So the power of this tool is that those Excel charts that we were looking at in spreadsheets are tied directly to this graphical interface, all in real time. If I adjust that margin percentage on a product by changing the cost of goods sold, all that information in that forecast will show up in this chart as soon as you refresh it. That way, across an organization, everyone's looking at the same source of data in real time. There isn't any versioning issues. All you need to do is open your report and refresh. And you can build your own custom views and reports tied to that same single source of data and look at these reports, whether it be in the web or in Excel. If you want a more static view, there can be PDFs made. That's included. The tool also will distribute those PDFs via email. All right. So that kind of concludes the things I wanted to cover about the predictive analytics. So we're going to open it up to questions. All right. We have one question from Joseph, which is better? Maybe we can get a little more detail as to which is better. It's probably referring to, before I go on here, basically if anyone wants to ask a question, they can type it in that little question box and it will pop up. So which is better? So I'm going to assume that means what version of BPC is better. There is a wide variety, and it really depends on your situation. I think the biggest question really is not so much the Microsoft versus NetWeaver, because that's really determined by your IT department's infrastructure. It's really classic versus embedded. And they offer different levels of integration. The embedded model with the way that's structured with real-time info providers can really, as soon as transactions are starting to be entered in with ECC, it can flow through all the way through BPC. So I mean that is a big advantage in some instances. For those users that want some more flexibility, maybe have a lot of non-SAP data sources that they're using, the classic model can accommodate those very, very easily. But there usually is some data latency. You're bringing data in from external sources, so there is going to probably be some form of staging of that data. And how often that data gets refreshed is kind of determined by the individual requirements of the company, but it's not as real time. But it can be made, a couple times a day typically, if that's the requirement. All right, let's go see what else we have here for questions. Oh, wow, we got quite a few. Okay. Can we use BPC Microsoft 10.1 with predictive analytics? Absolutely. It does not, the standard data tools that come with 10.1 will import it as a flat file. That's actually how we did it here, just to keep the demo simple. So you don't necessarily need to have everything on HANA for predictive analytics to work. Works fine with Microsoft version. Let's see here. So how is the predictive results determined? And the person here is asked, like, I have a background in statistics. He's asking very specific questions. Is it using exponential smoothing, all these different model types? So here's the catch. It looks at all the standard model types, and then it has proprietary models that SAP purchased from, I'm going to get the name wrong, I think it was Connexion, that look at the data and model it in its own way. And they actually have real data scientists at SAP with PhDs, and I've talked to them. And when I ask them the same question that you're asking me, they have a document that actually says about how much they can tell you about which model is being used. And I don't really get a satisfying answer. I mean, it kind of goes through most of the standard models, and that documentation's out there, but then it uses proprietary models, which you don't get a lot of information on. So, good question. I think probably the most important takeaway is that for each SKU combination, SKU store combination, it's trying to fit a specific model type to it and iterate through all the different available model types. Okay. So next one is, can the predictive model be used to model price points and costs driven by the change in commodity markets? So the earliest demo that we did on this was kind of exactly that. What we were doing, I believe it was cotton prices, and there were various inputs into, basically what were we doing? We were making t-shirts. It was a t-shirt factory, and our biggest input was the price of cotton, at least in the model. Obviously labor is another big one too, but so we were trying to model what was the impact of the futures market for cotton and the price of diesel fuel, because we figured that, it takes energy to harvest and ship the cotton around. So, that model, what we found was that it looked and said, well, as far as the cotton prices going into the t-shirt, the diesel fuel, even when it fluctuated, was not a significant factor in the price. Really, everything was captured by that futures market for the commodity. Like again, for these demonstrations that we're showing, I'm using very, very few independent variables. There really is not a limit. I mean, statistically, you have to kind of watch yourselves when you put 10 or more in. But you can be used for pretty much any, it's not restricted to any particular scenario. It's a very general tool, and you can use it for cost, you can use it for sales price points. For the purposes of this, bid units. So good question. So the tool behind the dashboards shown. So it's not a very good question. So when you are in the predictive modeling interface, that is a Fiori-driven application. It comes with the tool. The dashboarding that we looked at is basically, it's driven by technology, yes, but it is not a separate purchase. That dashboarding that we showed comes with BPC 11. Okay, some more questions. So does the user have the ability to kind of integrate with R-based models? With this tool, no. It's designed to be, the model selection is somewhat automatic. SAP does offer a predictive analytics suite that natively operates in HANA, which has got a lot more sophistication. But that's not really the target audience for this tool. Is there a limit in the number of inputs that the predictive factory can handle? I've not found one. I mean, I think it's more of a statistical question. If you're talking about the number of data points, there's probably some theoretical upper limit. I don't know what it is. I've not found it. It might be documented out there. The number of dependent variable or independent variables, you need to be careful, because if you give it so many, it basically can weight each one in a way that fits each scenario perfectly, and it's not really being predictive in the future. You run into statistical problems. Do the inputs for the predictive factory need to reside within SAP, or can pull information from outside sources? Excellent, excellent, excellent question. It can take any type of data as long as it fits if you can get it basically in a text format, and if you're doing a time series model, it needs to be tagged in such a way that it lines up with your time period. Those are really the only requirements. There are a lot of different data connectors, but at the end of the day, the default one is basically a CSV file. So if you can get it into that format, you can bring it into the tool. Next question. Okay, so a lot of good questions there. If you guys are interested in learning more about how this might apply to a specific scenario at your company, please reach out to Lauren. She can get in touch with me and we can talk more about it. I mean, this is a tool with wide application. And as we've seen, it integrates well with BPC. There are other tools that it could also work with, because while we had a nice, really slick import into BPC, you can use that output. Basically, I can provide that in a text CSV file, so even if you didn't have BPC, you could bring it into Excel. And if you did your planning that way. Now, I would say it would be, why are you doing your things in Excel? You should use BPC, but it's a tool that is independently offered from BPC. This works really well together. So again, thank you very much. And if you have additional follow-up questions, please send them to Lauren. If you want to talk more about it, Lauren will set up a meeting. And I want to thank you all for your time today. Everyone have a good afternoon. Goodbye.